Okay. Yeah, thank you. So today we will learn about the switching. Okay. How switching will, what is switching, what switch will do.
If
Okay.
you remember that.
So,
Hello?
hello.
If you don't mind, is this today like a first day for this classes or like in general it started 2 days back?
No, it is already started. This is the fourth
Mm.
class.
Okay.
And but this topic is new for today. Okay.
Okay. Actually,
So
I missed it 2, 3 days before, so I don't know.
you
So,
share me
is
your
there any
email.
link?
I'll share those videos. No problem.
Okay, can no worries, please.
Okay.
Thank you.
Right. Okay. So like switch. We discussed initially in the basics of networking, right? What a
Mm-hmm.
switch will do. Like switch, uh, for example, if there is a switch, if multiple devices are connected, like let's say, for example, one system is connected here, one is connected here, okay, and one is connected here, right? So first, what switch is a what it will do is which it will do, it will broadcast initially. What means by broadcast means whenever there is a frame or packet comes from one source or destination or from A to B or B to A. So if we don't know where it needs to send destination, for example, let's say here user 1, 2, 3. Here user A sending a frame to user 1. Okay. What switch will do usually, the once a frame is received from the system A to this switch, okay, first it will
Mm-hmm.
verify this frame. First, what a frame contains again. Before going, what will in frame we have a source address, we have a destination address, okay, we have like a protocol information, and we have data, okay, and we have payload information, that is nothing but payload information. So these many information we have. The moment switch receives this frame, it will verify, okay, from which source it is coming and for which destination we need to send. So it will filter these two information first. Okay, what is the source and what is the destination? Okay, once it is verified, first it will verify it's a what switch will do usually whenever new communication is coming. Like I said, it will verify source and destination. If source and destination is not there, then it will store this source and destination in one table. Okay, in one table, it will saves the source and destination information. For example, if A to 1, system A to system 1, if there is a connection, okay. So, for example, this is the source and this is the destination. Like that, if for example, if 1 is source, 2 is destination. It is not like this format, but just I'm giving example. Generally, it will be 00 AA or double B 00 like that. Okay. So, for example, now it will save source information and destination information. When if we don't have the saved earlier, right now the switch also don't know which destination it needs to send. So what it will do, it will say hello to all these switches. So for example, if this is sending a packet Y, okay, and what it will do, switch will forward this Y packet to all system A, system 1, system 2, system 3, right? Now
Mm-hmm.
what again return will happen? Now these systems will validate this frame if this have particular information which requesting from A. If it have, it's fine. It will again provide the response. If not, then what it will do? Okay, I received from this source this frame, but I don't have this information. Then again, it will give response back to switch. Switch it will give response back to you. The whatever information you are looking at or whatever destination you are trying to reach, this is not the right one. It will say this is not the right one. Okay. Then again, if similar concept will happen here. If its a destination is 3, now again same process it will happen. Switch this system 3, it will validate this frame. Okay, it will validate this frame, means it will verify the source and it will verify the destination information. Okay, now this is the
Mm-hmm.
right destination. Then now it will system 3 confirms. Okay, uh, what you are looking for information, like you want to reach a destination or you want to reach me, right? I am the right destination, right? Okay, I'm giving the response to you now, right? Okay, now now this switch understood. Okay, if for with this system A, if there is any frame coming towards the destination 3, I no need to broadcast again. Means broadcasting means sending a packet at a time to multiple resources, right? For example, if there is a frame is coming, this what it will do, it will distribute to all these systems. What will happen?
Mm-hmm.
It will unnecessarily we have to um, utilize our bandwidth, right? If I want to send a frame to all multiple devices when compared to single device, usually when sending to multiple devices, our bandwidth utilization will be more, right? For example, you are using a link, it is a 10 Mbps, and if you send multiple times to multiple location, multiple destinations, our bandwidth consumption will be more. Okay, so what next
Okay.
it will do? First time it will verify like this. Now, if second time it is coming, no, now switch will not broadcast to all these systems. Only it will directly forward this frame directly to 3. Again 3 to this system A, because it knows, right? Switch is saved this information. If I get any request from this source, okay, if I get any request from this source towards this destination, now I know both source and destination information, right? Now I will work like a unicast, like 1 to 1. If I again similar way, if I something 3 is trying to reach A, same, if we here also have multiple devices, then it will won't reach multiple directly, it will go to A, right? This is how switch will work. And while sending packet, there is a one condition. For example, this is a system and this is your switch. Okay, here your multiple devices are connected, whether it is a laptop or computer. Okay, what is one condition it will do? Even you can think here also multiple computers are connected. So if the moment if this is a computer A trying to send frame to this X, Y, Z, what it will do? Switch it will, I said broadcast, right? If it is connected to 6 ports, it will broadcast to all 5 ports except this port. Why? Because switch is an intelligent device. It knows I received the question itself from here. Then why should I ask question again to this only? So it will stop here, except this, it will broadcast packet to here X system, Y system, Z system, like how many systems you or how many sources are connected on the switch. To that many sources, it will broadcast the packet, except the frame which we are received on the port, except that particular port, it will broadcast to everything. So this is the condition it will use, or else there is a chance for the loop. I'm only asking where is this destination. Again, I'm only going back again. Where is this? Do you have this destination? If this have this destination, why should I it search for? Why should it send request to switch? because it don't have, then there is no point in asking question to this system. So that's why switch what it will do from wherever, whenever it is requesting, whenever it is getting request from any system, except that particular request, that particular system, remaining all resources, it will send the frame. By that, we can avoid the looping. Is it clear here?
Yeah,
Yes, sir.
bro.
Okay, that is one thing. Again, we have switches, right? If we have switches, we have types as well. L2, we can have L2 switches. We have L3 switches. What L2 switches will do, like we can call them as a manageable switches also. Sorry. Okay.
Layer 2 is sends packets only through MAC address.
Right.
Layer 3 sends
Correct.
with IP address and MAC address.
Correct. So now we can call them layer 2, layer 3 as manageable switches and non-manageable switches. So don't get confused with the L2, L3 and manageable and non-manageable. Okay. Okay. Now what is the difference between layer 2 switches and layer 3 switches? So layer 2 switches, it is like plug and play. Okay. If you want to communicate to one computer, just plug, right? It will work like a one setup box, and it deals with the frame MAC address. So this total L2 switches, it can understand only MAC language. Again, L3 switches, it can understand MAC as well as IP address. Okay. For example, we have one computer. We have one computer. Here also we have one computer, and here we have a switch. Now here it is sending frame to here, again coming to here, again coming to here. For example, if this is a system sending frame, so what layer this my layer 2 device can understand this communication frame, but my layer 3 also can understand the MAC, because layer 3 can understand both MAC and IP. Okay, now again we send request from computer this B. Okay, now it is sending IP information. So again request will go here and request go over here. So L2 switches, it cannot understand the IP address. So what will happen? So in switch, we will use a protocol called ARP. Okay. What it will do, address resolution protocol, it will do translate. Its job itself doing translate. If there is any IP request is coming from a layer 3 device, or IP, it want to reach IP to MAC, or MAC to IP. Okay. For example, let's say this is one switch. Sorry, this is one switch, and this is one switch. Let's say this is L2 switch. This is L3 switch. L2 switch only send frames. L3 switches can send frame as well as IP address. For example, if L3 switch is sending IP address, what will happen? L2 switch won't understand the IP address. So for that, what it will do, it will take the help of ARP. So what it will do, okay, fine. I will translate this IP address to your language MAC. Now L2 switch can understand the MAC. Now again, L2 switch is sending frame. Again, L3 device can understand both IP address, MAC address. No, then it can understand. Sometimes it will be system will be there. Okay, then it translate IP to MAC as well, or MAC to IP as well, right? It will do the translation jobs. Again, now, fine. Now
If you don't mind, what is the ARP?
it's a protocol. I said, right? Address resolution protocol. So
Okay.
in network, we have a multiple protocols. Each protocol, it
Mm-hmm.
have its own purpose. So the purpose of this R protocol. Again, we have protocols also, L2 protocols and L3 protocols. Right? We will
Mm-hmm.
discuss whenever as per the classes. But I will say in short term, layer 2, like we can say ARP is a layer 2 protocol. Okay.
Exactly.
Okay. Again, if any BGP or OSPF, these and all layer 3 protocols, right? So this is a protocol. Its function is translating IP to MAC and MAC to IP.
Yeah.
Now we are good. We
L1,
are,
L2.
yeah. Now we understood what is switch and what it will
Yeah.
do, how many types of switches, and what is the differences between these switches. Till here we are fine. And
Yeah.
first of all, why do we need to use the switches? Like you have a router. Okay, you have a router. You connecting to here. So there is a every network device have a ports like 8 ports, 16 ports, 24 ports. Okay, like that, or even 52 ports. So we have, what are the ports? Ports is nothing but where we will initiate the communication from. We will connect cable from to we in network is nothing but connecting of connection of multiple devices, right? So definitely, if you
Mm.
need to establish communication, we need have some physical media connectivity through cable. So what kind of cable it is, no matter. Based on the device type, based on that supporting mechanism, we will use the cable. So for example, if switch, oh, okay, when we have a router, we can use everywhere router, right? But for example, if you are getting, I'm giving example, if you get a router for 50,000, you get switch for 20,000, then which one you will prefer to, which devices you will prefer to buy more? Definitely we will buy switches. What I will do, I will take one connection from router to switch. Now again, I will divide my network here. So from here I will connect my multiple devices. So if I buy a one router, instead of buying one router, I can buy almost 2 to 3 switches, right? And moreover, so everywhere with each device have its own function. So based on our requirement, and as per our requirement, we have to use the devices. Okay, now you are going to connect some machines like computers, laptops, printers. So for that, you no need to do the routing. So there is no point in using the routing. A router we will use mainly for routing. For
Okay.
example, I want to communicate between the different networks. For example, here I have a 10.10.10 network. Okay, and you here you have a 20.20.20 network. So what layer 2 switches can do, it cannot perform the routing part. For example, if here switch is there, it cannot establish communication between these two networks. But if you have a router and if you have configured the routing here, then it will establish the communication between these two networks. Okay, this is the one more major difference between switches and routers. So that's why. So just I want to connect my computers where I don't require routing or I don't do any NATing. Then why I want to go for router? So I want to get the IP information or I want to get the frames. Then I can, for me switches are sufficient, right? Why I will go and pay more money? So that is the point. Okay. Now, right. Any questions in this?
No, sir.
What else? What next we will manage? Okay. One more. Why do we? One more thing. Whenever you are using a switch, no. In switch we have a like broadcast domain. Okay. In interview, they may ask question. Okay, you had a new switch. How many broadcast domains you will have? So by default, there is only one broadcast domain. Again, I will explain what broadcast domain is nothing but one complete network. So for example, I have a switch with 52 ports and I have a multiple teams like a HR team, uh, marketing team, IT team. For each 15 ports are sufficient. Okay. We discussed, right, in switch what will happen if any packet comes to switch, it will broadcast to all the resources connected on this switch, right?
Mm-hmm.
Okay, now I want to send a frame to particular HR team related to some candidate joining, or I want to send some documents. Now everyone can access this network. What I will do, IT person, will I sit simply? We are very eager, right? We want to know what is there. I'll go and take
Mm-hmm.
this remote machine and I'll also access those documents. Then do we have security? No. So that's why what we will do, whenever we will buy a new switch, we will divide this one single broadcast domain into multiple broadcast domain, right? But how we will divide this multiple broadcast domain? Just simple. We will use the VLAN concept. Okay.
Okay.
Virtual LAN. Sorry. Virtual
Okay.
LAN, VLAN. So what we will do, we are dividing this single broadcast domain into multiple broadcast domain. So now we have three groups: HR group, sales group, and IT group. So what I will do, I'll create a VLAN 10 for HR, VLAN 20 for sales, VLAN 30 for marketing. And I will assign different networks for these three groups. What my switch now I can only send to HR only. So since these are two different networks, switch can understand. Okay, this is looking for network 10. Then why it should forward this information to network 20 and 30? So definitely it won't forward. Moreover, so we cannot communicate with even as a physical device it is one, but virtually it is a three devices: one, two, three. So physically one, logically three. So logically it cannot communicate internally until unless we create some routing. So now we have security, right? Whomever, so we have three groups, but they cannot reach each other. But again, if you want to give access, we can give access. That is a network administrator. You have full control on them. You can manage them. You can, if you want, you can, as if you have a requirement, and with the proper approvals, we will provide the access. If not, we won't give access. Okay. In
Okay.
right. Any questions in this?
No, nothing.
Okay. Then we will stop this and we'll connect in 10 minutes. Then we will see some more part. Then we will go for the lab. Okay. How we will configure the VLANs. In VLANs also we have L2 VLANs, L3 VLAN that I will explain, and ports also ports type. Okay, that we will cover in next class, and we will join exactly after 10 minutes. Okay,
Okay.
and
If
meanwhile
you don't mind,
anyone,
yeah,
yeah, please go ahead.
if you don't mind, this networking also the one of the part in cybersecurity, right?
Yes.
Ah,
Okay, then thank you.
thank you.